Hello everyone, today we learn about the magnetic flux density Maxwell equation. As we learned before, electrostatic, the electric flux is denoted by D, and today we learn about the magnetic flux, which is been denoted by B. So the relationship is electric flux equal to permittivity at a free space time with the electric field intensity. Meanwhile, magnetic flux equal to permeability at free space time magnetic field intensity. The epsilon naught or permittivity at the free space equal to 8.854 times to 10 to the power of negative 12 and permeability equal to 4 pi times 10 to the power of negative 7 Henry per meter. So magnetic flux density B through a surface S is given by flux equal to the integral of surface B dot ds. So the unit flux is a Weber and magnetic flux density equal to Weber per square meter, Weber per meter square, or Tesla T. So we can see the magnetic flux lines, which is the line of the magnetic flux is toward to the northern pole. So from south to the northern pole. So the total flux through a closed surface in a magnetic field must be zero. So the total flux with the closed path B dot ds equal to 0. So by applying divergence theorems, so the integral of a closed surface S B dot ds equal to the integral of volume del dot B or divergent B dV equal to 0. From this, the magnetic field is not conservative, but magnetic flux is conserved. Why magnetic flux is conserved? Because the integration B dot ds equal the integration of volume divergent B dV equal to 0. So from the closed surface, the flux equal to Q and the surface must toward to south and go through to and outward to the north. So flux leaving a closed surface due to isolated electric charge. So flux equal to the closed surface of the integral of closed surface S d dot ds equal to Q. This is for the electrostatic. However, for the magnetostatic, flux leaving a closed surface due to magnetic charge from the south pole toward to the north pole, and the flux equal to the integration of the closed surface B magnetic flux dot ds equal to 0. To short, the divergence theorem of divergent B equal to 0. So this equation suggests that magnetic field lines are always continuous. This equation shows that magnetic field have no sources or sink. So remember the magnetic flux flow from south to the north, and the flux equal to the integration of closed surface S B dot ts equal to 0, or we can use the divergence theorem, divergent B equal to 0. From the Maxwell equation for static, electric, and magnetic field, so the divergent D equal to rho B or the charge density. This part is a electrostatic. So divergent B equal to 0. The curl E equal to 0 and curl H equal to J. J is a current density. This is a differential point. So Differential points means that divergent. So divergent D equal to density, current density, rho V, and divergent B is equal to 0. So how about the curl? The curl E equal to 0, curl H equal to J. So means that if divergence for electrostatic can produce the charge density, but curl for magnetostatic can produce the current density. So for integral form, d dot ds equal to the integral volume rho v dv, and this is called as Gauss law. And the integral closed path b dot ds equal to 0. This is, we call it, non-existence of magnetic monopole. So the magnetic monopole, divergent b equal to 0, and b dot ds, the integration of closed path, equal to 0. How about the conservative nature of electrostatic field? The cross E equal to 0, or curl E equal to 0, and the integral of E dot dl, the line dl, E dot dl equal to 0. So another law can produce is Ampere's law, which is the curl H equal to J, and the integral of H dot dl equal to integral S J dot ds. This is the Ampere law. So for electrostatic is Gauss law, and for magnetostatic is Ampere's law. Another one we need to remember, if divergent D produce the charge density and the curl H produce the current density.